All right, hello there. So I'm going to do section 12.5 with you right now. I'll see if I put some questions in Edpuzzle. I'm not sure if I will. It's pretty late this evening. As you can see, it's 10 o'clock, 10:01 p.m. on my screen here. And so, excuse me if I make a mistake or anything because it's pretty late for me. I'm an old lady. Anyway, so I'm just going to do part of section 12.5. We'll finish the rest in class and on Tuesday next week, and that's it. I'm just going to kind of go until I feel like it's enough or I get tired. So here we go. So think about a line in 2 dimensions. What do you need to be able to know? Like if you're trying to graph a line, you need to know 2 things about that line. You kind of need to know a point. And if you can think of it, the other thing you need is the slope, right? So you need a point and a slope to make an equation of a line. So that's kind of like the same thing that you need in 3 dimensions. So I'm going to write point and slope here. So you need to know like where it is. So the point kind of grounds you to where you are. The slope kind of tells you what direction to go in. So in 3D, you need similar information. In 3D, your point is going to be called x1, y1, and z1. And then your direction vector is what you're going to use for your slope. All right, so your direction vector is going to have these little vector brackets and has A, B, C are going to be the letters. Okay, so there is a line in 3 dimensions. So not everything has to be a plane in 3 dimensions. There are lines in 3 dimensions. All right, and so this is the equation of a line in 3 dimensions. There are 2 formats. So cross that off. We're only going to be doing 2 formats here. All right, first of all, there's parametric form. And you might have heard this word before in physics class. Parametric form is when something is broken into its x motion, its y motion, and now 3D, it's z motion. So all the different directions are broken up into equations for themselves. So parametric form goes like this. Has x equals, y equals, and z equals. Then you put x1, the x value of the point, plus a, the direction in the x direction, and then t. So t is your variable here. It's your, there's a special word for it, but I forget. It's just your variable there. So it's kind of, anyway, so then you have y1 plus bt, and you have z1 plus ct, all right? So before I take you and over to the next format, let's switch over to the next page. And oh, let me erase that because remember I did some of this on I was going to do it in a different video. All right, so if you want to find the equation of a line in 3 dimensions and somebody gives you a point to go through and a vector to go through, all you basically do if something's in parametric format, and parametric frankly is the most useful format. If something's not in parametric form, you kind of want to put it in that. So you got x equals, well my point starts off with 1, so I do 1. My direction in the x direction is 2, so plus 2t. Okay, and then y equals, I have negative 2 for my y value, and then plus 4t. And then z equals, I have 4, and the z direction here is negative 4, so I'll put negative 4t. So this is my direction. This is parametric form of my line. And you can see that over here. So over here in this picture, you have this vector, 2, 4, negative 4. And then you have this point right here. So what we've done right here is we've written the equation of a line that's parallel to this vector, but it goes to this point. So you see that's this line right here. Okay? And so then the next thing we have is a symmetric format. So I want you to tell me, and I'll see if I put this question in the Edpuzzle. If you looked at all these equations, what's the one thing that you could solve them all for? They all can be solved for what letter? All right, so I hope you wrote t. They all can be solved for t. So we're going to do that. So this format is called symmetric form. Like I said, the parametric's way more useful and used more often, but sometimes you have symmetric form. So we're going to solve them all for t. So if I solved the first one, if I solved x equal x1 plus at for t, I would have x minus x1, and then underneath it, that would be equal to at, and then I would divide everything by a. So my answer would be over a, and then this a would be gone. Okay, so here we go. So imagine that in your head. You'd have x minus x1 over a, And then the next one's also solved for t, so it's equal to this one because they're both equal to t. So I have y minus y1 over b, and the last one is z minus z1 over c. And so just in parentheses here, note that they're all equal to t, right? And so you don't really write that, but you know it to be true. Okay, so if you have to switch back to this format, then you have to remember that. All right, so over here in this next example, we're going to write it in symmetric form as well. So we're going to have three fractions. So in the first one, we're going to have x minus, and the point is 1 over 2. So you can also, since we wrote it in parametric form, you can also just kind of solve it in your head. You're going to have y plus 2, because it's usually y minus, but it's y minus a negative 2, so it's going to be y plus 2 over 4, the direction. And then the last one will be z minus 4 over negative 4, the direction. So this would be the symmetric format. Okay? All right. So this next example, find a set of parametric equations and the vector equation of the line that, so cross that off. So just parametric equations of the line that passes through these points. All right. So this is where things get a little bit annoying, and especially when I have to go and grade your papers, because it doesn't say which point you have to use. So your point, you could use negative 2, 4, 1 or 5, 2, 3 for your negative 3 for your x1, y1, z1. But you do have to be able to get the direction. Now, it also doesn't matter which direction you go. Like a line, you can go this way or that way, like it doesn't matter. So it doesn't really matter how we subtract these things, but why don't we kind of do it the old-fashioned way, and let's do like the last one minus the first one. So let's get my direction vector. So my direction vector is going to be 5 minus negative 2, so 7, 2 minus 4, so negative 2, and negative 3 minus 1, so negative 4. Okay, and then let's go ahead and, again, it doesn't matter which point, so let's go ahead and use this point. How about? So parametric equations of this line would be x equals, I would take negative 2 plus 7t, y equals, 4 minus 2t, and why don't you write the last one for me in your Edpuzzle? So that one would be, I would take 1 minus 4t. Okay. At what point does this line intersect the YZ plane? All right, so the YZ plane. So I'm going to use this picture up here. The YZ plane. So the YZ plane uses the Z-axis and the Y-axis. Okay, so the YZ plane is this plane that goes through these four things. So it's kind of coming across this direction. All right, and the y and the z-axis. Well, when you're on the YZ plane, that means that you didn't go on the x value on the x-axis at all. So the YZ plane, that implies that x is equal to 0 because you did not travel out or back or forward or backwards. Okay, so x is 0. So that implies if I'm on the YZ plane, that would imply that this x is equal to 0. So guess what? Negative 2 plus 7t has to equal 0. So then I would know that t, if I solve that, would be 2/7. So what point does this line intersect the YZ plane? So like we said, x would be 0, because also if I plug 2/7 into this problem, I get 0, right? And then I keep plugging in 2/7. So 4 minus 2 times 2/7, so now I'm plugging it into here. So that would be 4 minus 4/7. So that would be 24/7. I already worked it out, so you just trust me. All right, and the last one, I plug 4/7 into there, so that would be 1 minus 16/7. So that would be 7/7 minus 16/7. So that would be, no, I'm sorry, that's wrong. 8/7, sorry, not 16. All right, so it'd be 7/7 minus 8/7, so that'd be negative 1/7. See, it's too late. All right, so the next question, is this line parallel to this line? So why don't you pick out the direction vector for me? In your Edpuzzle, write down the direction vector for me of this line right here. All right, and I bet I tricked you. Look at this one right here. Do you notice how this is backwards? It's not supposed to be like that. It's supposed to be the x first, okay? So that one, if I write it like correctly, it really should be this. It really should be x minus 6, and then let's put the negative on the bottom. This is the same expression, right? This and this are the exact same thing. So actually, the direction vector, and I won't mark you wrong or anything if you got it wrong, because I should see if I could trick you there. The direction vector is actually -7, 2, and 4. All right, so when something's parallel, it has to have the same direction vector or a multiple of it. So let's take a look. And here was my old direction vector, and here's my new direction vector. Yeah, those are scalar multiples of each other. So 7, -2, -4. If you multiply it by -1, you get -7, +2, +4. So is the line parallel? I would say yes, it is. Okay. All right. So I think we're going to do this page and this page, and then we're going to stop and do the rest in class. Maybe those two. Maybe the next. Maybe not. All right, let's see. So what has to happen when two lines intersect? Because lines can intersect in space, or they don't have to. All right. So when lines intersect in space, it's because their points match, right? At one specific place, the points match. So when you have two lines intersecting, it's because at that point, the x, the y, and the z all match up. And so when two lines meet up, that has to be true. So if I hope to find the point of intersection of two lines, this line 1 and line 2, I need to see when x, y, and z equal each other. All right, so I already have equations in L1 right here for x, y, and z. I'm going to go ahead and change these to be also in parametric form. X equals, y equals, and z equals. Now, you can't use the letter t again because I've already used it as my variable in my other problem. All right, so I'm going to use, how about the letter a? So if I pretend all these are equal to a, I would have that x equals 5a plus 7. Then, what did I do this? 5 minus y over -2 equals a. So it'd be 5 minus y equals -2a. Then let's see, move my y over there and my 2a back. I would have y equals 5 plus 2a. So 2a plus 5. And the last one, easy, 3a minus 8. So these two things, this set of this line and then that line. So if these things are going to intersect, that would mean that the x's have to meet up, the y's have to meet up, and the z's have to meet up. Okay? So that's what we're going to write. We're going to write down a set of equations, a system of equations to make that true. So 6 plus t would have to equal 5a plus 7. -5 minus 2t would have to equal 2a plus 5. And then 1 plus 3t would have to equal 3a minus 8. All right, so you only have two variables and you have three equations, so you don't really need all three equations. So what we're going to do is we're going to pick the easiest couple equations. So nothing looks that easy, but I'm going to go ahead and select these two right here. I'm going to do a little algebra 1. I'm going to multiply this top equation by 2 so that the t's will cancel out. So that gives me 12 plus 2t, solving systems of equations, like addition method, equals 10a plus 14. The bottom one stays -5 minus 2t equals 2a plus 5. And I'm going to go ahead and add these. So this goes away. I get 7 equals 12a plus 19. Subtract 19, so I get -12 equals 12a. So a must equal -1. And using those same two equations, if a is -1, then let's see, how about we plug a is -1 into this top equation here. I would get 6 plus t equals 5 times -1 is -5 plus 7. So 6 plus t equals 2. So t would have to equal -4. All right, so let's test it out. So these things are going to meet up when a is -1 and t is -4. So this is the test. If I know these two numbers are going to work. These two numbers are going to make this and this match this and this, because those are the two equations that I used over here. But it's the third one. The third one will be the test. If the third one matches at whatever it's going to be, then I know that these things meet up. All right, so let's do it. So if I do it with L1, let me get a different color here. If I do L1, if I use in L1 t equals -4, I get this point. I get 6 plus -4, so I get 2. I get -5 minus 2 times -4, so that's -5 plus 8, so that's 3. Then I get 1 plus 3 times -4, so 1 plus -12, so that's -11. All right, so let's try it in L2. In L2, if I'm going to use over here, I'm going to use a equals -1. If I plug -1, 5 times -1 plus 7, guess what? I get 2. And then for y, I get 2 times -1 plus 5. I get 3. Looking good. It should look good so far. And then this is the test. 3 times -1 minus 8. So it'd be -3 minus 8. It's -11. So yay. So you have found the place where they meet. This is the point where they meet at, and they do meet. All right. So let's do this one last problem on the next page, and then we will be done. So do you remember what skew lines are? So skew lines are lines that are in different planes. It's like they're lines on parallel planes. So if you had, I'll show you in class also, but if you had a plane and then you had another plane that was like parallel to that one, this drawing is going to be horrible, you guys. All right. And then what happened was you had a line on this plane, and then you had some other line on this plane. Those lines would never touch because they're on parallel planes. So those are called skew lines. So skew lines are just lines on parallel planes. They're never going to touch. They're going different directions, but they lie on parallel planes. All right. So here's this last problem here. So what two situations would happen where lines don't intersect? So the answer is that they would be on skew. The lines are skew. So lines are skew, or they're parallel. Okay. All right. So my last example here, prove that the two lines here do not intersect. So first of all, I'm going to check, are they parallel? So are they parallel? Let's see. So the first line, line 1, goes like this. X equals 2, y equals -1 plus lambda, and then z equals 2 lambda. Line 2 is x equals -1 plus mu, y equals 1 minus 3 mu, and z equals 1 minus 2 mu. All right, so for these lines to be parallel, they have to have the same direction. Well, look at line 1. The direction would be 0, 1, 2. Line 2, the direction would be 1, -3, -2. That's not a match for 0, 1, 2. All right, so they're not parallel. So that's a no. All right, so that was a easy, quick test. Whoopsie, not parallel. So let's prove another way. Another reason they don't intersect is because they're skew. All right, so remember, I can take any two of these and set them equal to each other. So I'm going to use these first two. So 2 equals -1 plus mu, and then -1 plus lambda equals 1 minus 3 mu. All right, so hey, this is an easy one right there. So this means that mu would have to be 3. If mu is 3, I'm going to plug that into there. So I get -1 plus lambda equals 1 minus 3 times 3 is 9. So that's -8 equals -1 plus lambda. So lambda would be -7. All right, so I'm going with those two things. So let's try them. So if I try those two values in my equations, let's see what we get. So over here on the left, lambda. So x is always 2. That doesn't change. Let's see. Y. I get -1 plus -7, so -8. And then 2 times -7 is -14. Okay, so now let's use mu. So mu equals 3. So x, -1 plus 3, oh, 2. Yeah, I was expecting that because I used that equation to solve over here. On y, 1 minus 3 times mu. So 1 minus 3 times 3, so 1 minus 9, -8. I was expecting that. Now here's a real test. If the last one doesn't come out to -14, then these must be skew. All right, so let's see. I plug 3 into that. So 1 minus 2 times 3, 1 minus 6 is -5. And so they do not meet up. They must be skew because they weren't parallel. Okay, and that is it. I'll see you in class.